Hi guys, welcome to Stability and Bonding Part 2. This is going to be a continuation from our notes from last class. You can go ahead and title it at the top of your page or at wherever you finished off the date. Flip Notes from Stability and Bonding Part 2. Just like our other flip note videos, you're going to go ahead and write everything that's read into your composition notebook. Tonight we're going to be talking about capital letter C, chemical bonds. Ooh, very chemical. This one's my favorite. Unfortunately, we don't have enough time to talk about them. We're going to be talking about atoms bonding instead. Almost as exciting, almost. Okay, so first let's start with why do atoms form a compound? That's a pretty important question, and let's do a little learning check. So if we look at the Lewis dot structure of this mystery element right here, it has one electron in its outermost valence shell. Which of these three would look most closely like it? So go ahead and pull out your periodic table, and the correct answer would be sodium. What about this guy down here? 5 outer valence electrons is going to be nitrogen. Sodium's in group 1, nitrogen's in group 5. So why do atoms form compounds? Well, number one, atoms find stability by sharing, giving, or taking electrons from other atoms. So you can kind of see here in this picture down here, one of the most famous compounds there is, water. Hydrogen has 1 in its outermost valence shell. This hydrogen has 1, and the oxygen has 6. So what it does is they each share 1 with each other, thus completing their outer valence shells and becoming happy. So why do atoms that do not have a full outer valence shell do? They bond with other atoms to try to fill up their outer valence shell and thus achieve stability. So they either give, take, or share electrons. We're going to be talking about one of the methods of bonding tonight. And they do that to become stable. So you're only stable when your outer valence shell is full. So how do atoms form bonds? Well, they do it in 3 ways. They give, take, and share just their outer electrons. That's why that outermost shell is super important. Now, when they give and take, we call that ionic bonding, and when they share, we call that covalent bonding. Tonight, we're going to be talking about ionic bonding, so go ahead and write A, ionic bonding in. When atoms give or take outer valence electrons from other atoms to fill up their outer valence shell, that's what we call ionic bonding. So let's go ahead and look at salt as an example. Think of sodium in its elemental form. You might not know much about it, but let's decide if we think it's stable or not. Doesn't look very stable there, but let's go ahead and do the Lewis dot structure for it. You're going to have 1 outer valence electron sitting there in sodium's outermost valence shell. Now let's pretend that's you coming to class one day and all of a sudden nobody else is there. You'd be pretty lonely sitting in class with me. You'd be like, I've got to get out of here. This is crazy, right? So sodium, just like you, wants to lose that one lonely electron. You kind of want to leave the class. So because once it does lose that outer valence electron, its next innermost shell is full, it can become stable by losing that outermost electron. So what does sodium do? Sodium wants to lose that one lonely electron, so it lets another atom take its outermost electron away. Now that that one electron in its outermost shell, its third shell, is lost, we look to sodium's second shell, which is full. So why do atoms form compounds? Atoms try to find stability by bonding with other atoms. Atoms want to have what we call a full outer shell, or we call that a full octet. Again, octet coming from 8, and 8 being the full outer valence shell. And it costs the same amount of energy to lose an electron as to gain one. Therefore, sodium wants to get rid of that outer electron because it's way easier to get rid of the 1 than go and try and find 7 that are around there. So let's look back at sodium. Where did that electron go? It can't just send it off into space. There's got to be somebody that's willing to take it. So there's a little electron. See ya, I'm out of here. Well, electrons can't disappear. The goal is to have a full outer valence shell, so which atoms may want to gain an electron? Don't worry, I didn't go too far. Well, atoms that have 1 empty spot. So which group are we going to look at? We're going to look at group number 7. You look at chlorine, iodine, fluorine, bromine. Those are all elements that are looking for one more electron. You can see right here, chlorine finds it and is very happy with what it found. So it's much easier to gain one electron to make a full octet than to lose 7. Chlorine's not going to send away its 7 electrons. It's going to do its best to find one to become full. Electrons are lost or gained to make an atom stable, and as a result, we call that a compound that's formed. Here's another example of a compound between potassium and fluoride. That potassium atom gives up its outermost valence electron to fluorine. Now, what happens to the charge of the atoms if they gain an electron? So remember, electrons have a negative charge. So if it's gaining an electron, it's gaining negative energy, and that means it's going to become negative. And the potassium atom now has lost one negative energy, which means it's going to have one more positive energy in there, and it becomes positive. We call this an ion. Anytime you gain or lose an electron and you're no longer neutral, remember I kept talking about how up to now all atoms were neutral, now they're not, we call that an ion. So here's our definition of ion. It's a positively or negatively charged atom resulting from gaining or losing an electron. And this compound is called potassium fluoride, and it consists of potassium, K+ ions, and fluoride, F- ions. We call the positive one a cation. That's a positive ion, for example, K+, and the negative anion is my negative ion, which example would be F-. So make sure you go ahead and put that in your notes. The attraction between the cation and the anion keeps the compound together, and that's what we call the ionic bond. So the ionic bond is the attractive forces coming together. Now that little plus and minus is called my oxidation number, and it tells me something really important. The oxidation number is the superscript that indicates how many electrons have been lost or gained. In this case, if you don't see a number, you assume that it's 1, but sometimes you can gain or lose more than 1. You might gain 2, you might lose 2, so then it would say 2+ or 2-. Now in ionic bonding, it always occurs between a metal and a nonmetal. So anytime you look at, oh, and I think I might have done that wrong. This is my metal, this is my nonmetal. Oops, don't pay attention to the arrows. Anytime you look at a compound, you can tell that it's an ionic bond if it consists of a metal and a nonmetal. So why do some atoms like to give up their electrons while others keep them? Well, we call this electronegativity, and it has to do with that basic concept of it's easier to get rid of one than gain 7. Electronegativity is the ability of an atom to attract electrons. So you can be very attractive to electrons if you have a lot of them, and if you don't have a lot of electrons, you're not very attractive and it's easier to give them up. Metals have a low electronegativity because they don't have very many electrons. It's easier for them to give them up. And nonmetals have a high electronegativity. The low electronegativity means that they're more willing to give up their electrons, and high electronegativity means they're not willing to give up their electrons. Again, we've got my metal and my nonmetal here. Let's do a little review. And what are these charged particles called? Anybody know out there? Yes, we call them ions, but specifically each ion is a cation and an anion. And what's that number up there at the top? Yep, it's an oxidation number. And what is the oxidation number? It indicates if the ion has gained or lost electrons. So let's look at a couple other examples right now. We're going to draw the dot structure for Mg. So find Mg on your periodic table. And when you do that, you'll see that it's in group 2, so it has 2 outer valence electrons. What do you think Mg wants to do with those 2 outer valence electrons? Is it easier to get rid of 2 or gain 6? Probably wants to get rid of them. But where could they possibly go? It's got to find somebody that needs 2 electrons. Couple takers out there. We got O, we got Se. They're going to fight over Mg's electrons, and up, looks like O gets them. So O's like, sweet baby, let's bond. I'll take your electrons. So when Mg gives its electrons to O, it loses 2, and it becomes 2 positive. O gains 2 electrons, and it becomes 2 negative. And these guys cancel out their charges, and the overall compound that's formed is neutral. All compounds are neutral because the charges should cancel out. And that's a little picture of what we did in class when we burned the magnesium, because Mg plus O makes magnesium oxide after you burn it. So that's what we did in class as our little experiment. So let's look at one more. How would the following elements form an ionic bond? We have sodium and oxygen. So let's look at the chemical formula of this. We have to determine the chemical formula, and we'll start with our Lewis dot structures. So let's go ahead and do sodium and oxygen. We've seen these two before. Sodium has 1, oxygen has 6. So sodium's going to want to get rid of that electron and give it to oxygen. But oxygen's not happy with just 1 because it still has an empty spot. So if sodium and oxygen were bonding and those were the only 2 elements, we'd know that there must be another Na in the formula. And that Na is going to give its outer valence electron to oxygen. So now that oxygen is happy, it's gained 2, and my 2 sodiums have lost 1. Remember, it's kind of counterintuitive. They've lost an electron that gives them a positive charge. Oxygen has gained 2 electrons, that gives it a 2 negative charge. So the chemical formula for this would be Na2O, 2 sodiums and 1 oxygen. Oxygen has an oxidation number of 2 minus because it needs 2 electrons to fill its outer orbital. That's another way you guys can look at it. And the opposite attractive forces keep this compound together, and that's what we call bonding right there. So last but not least, a little learning check. Why do atoms form compounds? Atoms try to find stability by bonding with other atoms. Atoms want to have a full outer shell called a full octet, and it costs the same amount of energy to lose an electron as to gain one. So make sure to get all the red, including this, into your notes, and tomorrow in class we'll be talking all about this.